Okay, so almost there for today. So all that remains for the session is to just quickly look at the ARDL. And what I will use as an example for that, if you go to the practical application, under the exports function, there's that one example, co-integration 3 ways. And there is I would open this file for the discussion, and where's the document, the PDF? Oh, I think this one is the discussion, and the EViews file is where the last one. So the last 2 documents, open them. That EV settings is just one of the temporary files. I can actually delete that. So from your folder, you can open the instructions and the data is there. And the ARDL is discussed from page 20 at the bottom. It's the 3rd method. And this is the example where we work with exports. And remember that last summary page? Although we haven't estimated this one here, we haven't estimated the others, but this is applying the Engel-Granger method, applying the Johansson method, so you can do that on your own. And now we're just going to see that we get these results, which are pretty much in line with the other methods. Just like the money, when using Johansson and using Engel-Granger, give us pretty similar, robust results. So in this document, this is the second last page. I need you to go just 4 pages up to page 20 bottom, and we'll look there. So this is the example where we expressed relative prices as export prices over world prices. And we control were for democracy and for financial crisis. So how will we do that? I can maybe try. This is slightly bigger. So first step, let's just determine the VAR. Just the ARDL, I mean, that's the original VAR story, the autoregressive distributed lag model. So, and only for those 3 variables, and then controlling for democracy. And here we use that dummy where we smooth democracy across a number of periods. So exactly what the values at this moment is, you can check that. That's not so important. So how are we going to estimate an ARDL now? We're going to open it as an equation, not as a VAR, as an equation. And then we're going to estimate, but not we're not estimating a least squares models now. We are going to go to the ARDL option here. It's the 4th last option in the estimation settings box. Under method, we select ARDL. And now we have lots to explore. Sometimes if you see people explaining things, they will say, go ahead, fool around with this. So we have a lot of control, and actually these asymmetric dynamic specifications is a new addition that wasn't in the previous version. So we have our three variables here in the dependent variable, followed by regressors. So this is Alex, LYW, and L rel P, log of relative price, and our dummies go here. The fixed regressors are dumb democracy, and make sure you select the one with the 0, 1. And then the financial crisis is the second one. And that's all that we need to do now. That will now estimate an ARDL model that we can go further with. You will always also see for many of these things, they give us now more information. That sometimes it feels like now it's not so easy to see. You can see they put headings now, but who doesn't know Alex is the dependent variable? The independent variables, the deterministic and the fixed regressors. I mean, I think we could have seen it here, but this is now what we have. The coefficients do not change. But this is just the first step. Now we have to determine the order. If you go to view, and it has already given us the optimal one, but let's just, if you go to model selection and go to criteria graph, that is where it will run many models and give us the best 20. And an ARDL is implemented that you can have different. Those three numbers there refer to the three variables. Exports, world income, and relative price. So the first one says how many times export will be lagged. Second number, how many world income will be lagged, and that will be relative price. So the second best fitting model is the one where exports are lagged 3 periods. Okay. So we start out by, let me just start all from scratch. I select my 3 variables. I open as an equation. Remember with Johansson we go to a var. Here we go back to equation like Engel Granger, but we don't select the least squares. We go all the way down to ARDL. We let it automatically select, and we just specify this 4. If you want to allow for 6 lags, you can make it 6 potentially. And the fixed regressors we add here. Democracy 0, 1, space, financial crisis 0, 1. It's very similar to the original variables. I think we just smoothed, apply weights to the democracy dummy. And later on, if you think there are asymmetric effects, we can add some of that there. And this is now similar to what we've seen here, just with some subheadings.
Hello.
Yes.
I'm getting 3 likes of predictability.
Yeah, Sam, I'm getting completely different.
For some reason.
Let me just, it can be that you haven't put in the exogenous dummies. Go to estimate again. 4 automatic. This.
And the variables are LX, LY, W.
Log of real prices. Log of relative price. Yeah, if you do slightly different, if you maybe have selected not these dummies but the other dummies or not dummies at all, it is possible to get. And Claretta, then we go to view, model selection, and there we look at criteria graph or criteria table. And it will compare the best 20 models, and it looks like the higher orders also feature here. But unless you change it to fixed or something, it will work further with this preferred model. So if we estimate now we have to go through the motions, and what you approach first is probably want to test for co-integration. In this step, the bounds test and the long run was one option, long run and bound test. Now it's split up. You have to view ARDL diagnostics. Here you get the bounds test, and here you get the long run relationship. So let's look at whether we have co-integration first. So if you click on bounds test, and even that looks a little bit different. You see, this is what it used to look like. They've now changed it not to give you the actual number of observations. They give you like 30 and 35, and you have to decide, is 33 now closer to 35 or 30? I will just go with the one that's more strict, so I will work with the 35, which have larger. If you exceed these critical values, you will exceed the lower ones. So how does the bound test work? The bound test is like the Durbin-Watson test. There's a region that's undefined. To have co-integration, we want the F-stat to exceed the I1. If we want to work at 5%, we want the 25 to be bigger than the 4.35. If it's smaller than 3.47, there's no co-integration. And if it's in between, it's undefined.
So what will you be the solution when you fall in the undefined region after I've tried everything?
I will try with adding a different dummy, different variable, different specification. Go back to your structural breakpoint test, rethink what you want to add to get to a place of co-integration. Nothing changes there. So we take that value, we compare it to that 4.3. Or if we want to work at in this case, it's bigger than the 1%. So we have co-integration at the 1%. In my experience, one get most easily find co-integration with the bounds test approach. Maybe that's one reason why it's very popular. I shouldn't say that.
It is. If you check most of the German tests,
Yeah.
almost everyone says the bounds test.
Yeah. I will always, you can even, it's always a good thing to then also report the Johansson test, even if it's in a footnote, to still confirm I have one co-integrating vector. The next step is to see what the long run looks like. The long run here is what we have up here, levels equation. We have that 1.089 minus 0.03. And it used to give you that in any case. I didn't type it in. I just highlighted in blue. So let's see if we can get the same. So if we view ARDL diagnostics co-integrating relationship, there I have my relationship, and here it's written up here. So they just, with this wizard, they now have, they're just juggling things around. So maybe the last thing is then to see what the error correction model is. And we need to see if it's the same as what we have here. So we just have to go to view ARDL diagnostics error correction results. And again, it's a little bit so here is my error correction term. You can see that it's almost now it's more difficult to read the output. I think down here it's a little bit more. You see here it's in the second. There's the speed of adjustment. There are my long run parameters, and here are my fixed regressors. But where's my dynamics? Oh, those two. Oh, since it's an ARDL 1.1. This is already the dynamics. And there's the error, the co-integration term. And if we compare that, again, it is very similar to the other methods. And then we can't escape this. The classical violations, we still have to go through the motions by going to the residual diagnostics and testing for normality, zero correlation, heteroskedasticity, and the stability diagnostics, looking at the Ramsey reset and the recursive estimates. And that's the method. And documenting then, that will be similar to this. If you feel it's necessary, then we can do a little bit more tomorrow, but I promised we will be done early, so we have to stop now.